In this video, we are going to learn about the binomial theorem and Pascal's triangle. Now, we have been trying to find out the squares and cubes of various numbers. Okay, and particularly for binomials like a plus b or maybe a minus b. So let's test it out for a plus b. If you have to find out a plus b to the power 0, you know the answer, right? We know a plus b to the power 0, or for that matter, any number raised to the power 0 is equal to 1. Similarly, if you have to find out a plus b raised to the power 1, you know this is equal to the number itself, or a plus b. Right? Let me complicate it a little bit further. Let's find it out for a plus b whole square. Now, we've been looking at it in quite some details earlier, so I'm not getting into the detailed calculation, but this is again equal to a square plus b square plus 2ab, right? Or maybe let's write it down as a square plus 2ab plus b square. Now, how about a plus b to the power 3? Again, this can be found out. A plus b to the power 3 can be written as a plus b into a plus b whole square, right? But this we've already know value is this, so we can write it at a plus b into a square plus 2ab plus b square, right? Or we just do the multiplication, so we get a into a square plus 2ab plus b square plus b a square plus 2ab plus b square. Or if you open it, you get a cube plus 2a square b plus ab square plus b a square plus 2ab square plus b cube, right? Or if you just see, we can also write this as a cube plus 2a square. We don't have anything else with a square here, so we just write it as 2a square b plus ab square. We also have 2ab square here and 1ab square here, so 3ab square plus b a square b, right? Which is also what we have here. So instead of 2, we can write 3a square b, right? Plus b cube, right? So this can also be written as a cube plus 3a square b plus 3ab square plus b cube. Similarly, you can also write a plus b to the power 4. Now, I'm not getting into the details of how do you calculate this, but this basically, if you find out, is going to be a4 plus 4a cube b okay, let me just erase this part to create some space. So these are some of the variants. But let's say if you were asked to find out a plus b to the power 12, how will you do it? It's going to be extremely complicated. At the same time, the chances are that you will mess up at some point of time or the other. Now, to find out the squares of a binomial, okay, squares or any raised to the power, the binomial theorem was propagated. Binomial theorem basically gives you a simplified way of calculating power of any given number. So let's say if you have to calculate a plus b to the power 12, how will you do it? Let us see. So before understanding the binomial theorem, let's understand what is a Pascal's triangle. Now, if you notice, what has happened here is that the number of terms in the expansion, okay, is one more than the index. Index means basically this power. So if you had the power of 0, the total number of terms was 1. When the power was 1, the total number of terms was 2. When this is 2, it's 1, 2, 3, and so on. Okay, so this is one property which you need to keep in mind. The second property is that the power of A, or the first quantity, keeps on decreasing by 1. So basically, if you notice here, what do you have? You have a to the power 1 plus b. Now b can also be written as what? A to the power 0 into b. So the first quantity power keeps on decreasing by 1, and second increases by 1. So in this case, let's say for example, let's take this one. So the power of A is 2 here, 1 here, and 0 here, whereas power of b is 0 in the first one, because b to the power 0 can be written as 1, 1 in the second one, and 2 in the third one. So the power of the first quantity, or the first variable, or maybe the number, not necessarily a variable, keeps on decreasing by 1, and that of second keeps on increasing by 1. But the sum of power of both is equal to power of binomial, or basically is equal to the index. So if you see here, the power of index is 1, so a to the power 1, b in any case is 0. Let's take it in this case 3, so a to the power 3, b is 0, so 3 plus 0, 3. The power of a is 2 here, and b is 1, so 2 plus 1 again 3. Power of a is 1 here, b is 2, 2 plus 1 again 3, right? So these are some of the properties which arise in case of powers. Now let's form the Pascal's triangle. A Pascal's triangle is basically formed by taking the coefficients of each of these successive numbers. Okay, so let's say in the first case the coefficient is 1. Let's also write down the index. Right? In the second case, what is the coefficient? 1, 1. So the way we write is 1 we write to the left and 1 we write to the right. Then the power is 2, right? So again, the way this works is that 1 has to be on the either sides. Okay, so let's say you have 1 here and 1 here. Okay, now how many terms will this thing have? The index is 2, so the number of terms has to be 3. We already have 1 and 1 here, so there has to be one more term. What will be the coefficient of that term? The coefficient in the middle is calculated as the sum of two numbers on the either side. So you have 1 and 1 here, 1 plus 1 is 2, right? Again, the index is 3, so the number of terms has to be 4, right? Because 1 has to be on the either side, so you put in 1 here and 1 here. right? As I told you, the other two middle terms has to come here and here. These are to be taken as the sum of these two numbers. So 1 plus 2 you write in the middle as 3, 2 plus 1 again 3, so you write it down as 3, right? Similarly 4, so the number of terms has to be 5, 1, 1. Now take the middle term between here as the sum of these two. So 3 plus 1 plus 3 gives you 4, 3 plus 3 gives you 6, 3 plus 1 gives you 4. And these are exactly the coefficients which have come on the left side. So let's say for example in this, the coefficient of the first term is 1, second is 4, third is 6, fourth is 4, fifth is 1. Right? So this is basically this formulation of the coefficient of various powers of a binomial is known as a Pascal's triangle. But the problem, as I said, is that if you have a plus b to the power 12, if you start increasing it, this will take you a long time, right? So is there some easier way of doing this? How can we find out what is a plus b to the power 12? Now if you use the knowledge that you had gained earlier, okay, in terms of the combination, where an NCR is equal to factorial n upon factorial n minus r factorial r, okay, and you rewrite these numbers, all of them, okay. So let's see how does it comes to. You have 1 here, right? You have the index as 0. So we try to write these numbers or the coefficients as are appearing in the Pascal triangle using the index given as a result of combination. So 1 can be written as 0, C0, right? Similarly, if you move on with the index 1, basically the index given here is equal to n. N is equal to the index. So again you have 1 here. So 1 can be written as 1C0, okay, and this can also be written as 1C1, right? Similarly for this one, how can you write this? You can write this as 2C0 because that is equal to 1. We know that NC0 is equal to 1, right? So when you have to write this in terms of the index, you can always write this as 2C0. Now 2 can be written as 2C1, right? And this can be written as 2C2 because we know that NCN is equal to 1. Similarly, if you have to write the value of 1 in terms of 3, you can always write this as 3C0. 3 can be written as 3C1. Then again you get 3. Now 3 can also be written as 3C2. And you can do these calculations at your end. But let me show it to you. 3C2 is equal to factorial 3 divided by 3 minus 2 factorial 2. So this will become factorial 3 upon factorial 1 into factorial 2, which is basically equal to 3. And this can be written as 3C3. Now if you try to generalize this Pascal theorem for any index n, okay, whether it was 2, 3 or so on, right? This can be written as NC 0. Then you got NC1. Then you got NC2. Until and unless you reached NCN. So basically NCN, let's say for example in this case you had 3C3. So 3C3 was the last number, right? Now the first term was A. Now the index of A is always equal to the index of the binomial, right? So let's say this has to be equal to n, because that's the index of the binomial, right? And the index of B is 0 to start. Now as you move to the second one, basically this will become A to the power n minus 1 and B to the power 1. Why? Because A power will reduce by 1 and B will increase by 1. Similarly here, n minus 2, B to the power 2. And ultimately A will become 0 and B will become n. So this theorem, which is so formed, is known as the binomial theorem. Now let's say for example if you have to find out A plus B to the power 12. Okay, so this can be easily found out by 12C0, A to the power 12, B to the power 0 plus 12C1. Okay, then A to the power 11 reduced by 1, B to the power 1 plus 12C2, A to the power 10, B to the power 2. A will keep on reducing by 1, B will keep on increasing by 1, and so on until you reach 12C12, A to the power 0, B to the power 12. And once you find out the value of all this, you will have the value of the binomial.